So in the previous completed compressibility factor. Okay.
Yes.
Now we will study about wonder gas equation or real gas equation. So we will get an equation with the help of ideal gas equation. As we already know about ideal gas equation, that is PV equals to nRT, and the deviation is caused due to two major assumptions, that is because of force of attraction and pressure. Okay. Wait a minute, I will explain how we will get real gas equation or van der Waals equation. So as you know that if this container contains ideal gas and this container contains real gas. So according to the assumption, we know that in ideal gas there is no force of attraction between gaseous molecule. Do you remember it?
Yes.
There is no force of attraction in ideal gas. So if a gas molecules go and collide with the walls of container, this gas molecule will collide with full force, with full velocity. That means there is no force of attraction between gas molecules. It means it will collide with full speed, Whereas if we are going to talk about real gas has force of attraction between gas molecules. So if a gas molecule going to collide with the walls of container, there is a lot of other molecules of gas which is attracting this gas molecule towards themselves. Just see, if this molecule of gas going to collide with the walls of container, the nearby molecules will attract this gas molecule towards themselves, and it will not go with the full speed. It won't go with full speed. That means the pressure that exerting in ideal gas equation is more than the pressure exerting in real gas equation. Is that clear, Akifah?
Yes.
Because in ideal gas there is no force of attraction between gas molecule, so it will collide with its full speed, whereas in real gas other molecules of real gas will attract that gas towards themselves, so it won't hit the container's wall, it won't hit the walls of the container with full speed. That means the pressure exerted in ideal gas is more than the pressure exerted in real gas. Is it clear?
Yes.
Very good. So you know that this is ideal gas equation, and this pressure in ideal gas equation is more than the pressure in real gas equation. So here is a pressure correction term. Pressure P real is equal to P ideal plus AN square upon V square. This is the P real and this is pressure correction term. And another factor which is responsible for deviation is volume. in KTG, the assumption that is also called postulate, I told you that the volume of ideal gas is negligible in comparison to the volume of container. So basically, volume of ideal gas is negligible according to the assumption. So here it will be V real, and actually I told you that the volume of real gas is something that is occupy the volume of real gas is negligible, but the volume of ideal gas is negligible, but volume of real gas is not negligible. So V real will be V minus NB, and this is basically constant, and you can also call it volume correction term. Volume correction term. So here we will have a real gas equation, that is P plus AN square upon V square into V minus NB is equal to nRT. This is called real gas equation, also called van der Waals gas equation. And what is ideal gas equation? PV is equal to nRT. This is ideal gas equation. Ideal gas equation. So from this equation we got this. Okay.
Okay.
Is that clear?
Yes.
Okay. Just write it and let me know if you have any doubt regarding this. If you are done with this, let me know, please.
Can you scroll down?
Yes, yes. This will be P ideal. P plus AN square upon V square. V real, and V is equal to this much. This is container. So basically P ideal is equal to P plus N square upon V square, and that P stands for real gas. This A and B is called van der Waals gas constant. I will write it.
Done.
Done. where A and B are van der Waals gas constant. Or real gas constant, always also called the real gas constant. Let me know if you are done with this. Then I will have some question. I will give you some question according to.
Done.
Okay. Write a topic, significance of A. Significance of A. The value of A gives the magnitude of attraction of force between gas molecule. Force of attraction between gas molecule, and how will we determine basically which gas has more attraction and which gas has less attraction. First point to determine is, if a gas is polar, that will have more attractive force than non-polar gas. Non-polar gas. And if both are polar or both are non-polar, then how will we determine molecular weight directly proportional to van der Waals force of attraction? Van der Waals force is directly proportional to molecular weight. If a gas is both the gases are polar, then we will go for molecular weight, and both the gases are non-polar, then we will go for molecular weight. And if a gas is polar and non-polar, the polar molecule has more attractive force, or the value of polar molecule of gas of A is greater than non-polar gas. Is this clear?
Yes.
Okay. Let's take an example which is very important. A. Here is NH3 and Cl2. Just think about what do you know about this? Tell me which one is polar and which one is non-polar, or both is polar or both is non-polar. What do you think about NH3 and Cl2?
Cl2 is more polar.
Yes. What about NH3?
NH3 is non-polar.
Non-polar. Cl2 is non-polar because Cl, you can see Cl has equal electronegativity as equal. Cl, both are Cl, so electronegativity of Cl is same. So if this Cl will attract electron with the same force, it will attract its electron. Okay, so it will be non-polar. It will be non-polar. And what about NH3? NH3, you will see this polarity and non-polarity arises. One of the reason is due to electronegativity difference. Do you know which one is more electronegative, nitrogen and hydrogen? Which one is more electronegative?
Nitrogen.
Nitrogen. Nitrogen will attract towards itself this hydrogen from this hydrogen 2 and from this hydrogen 2, and lone pair will attract its in a direction like this. And you can see this is not cancelled by each other. If you will go for resolution of vector, which you have studied in physics, do you know how to resolve a vector?
Yes.
If a force is inclined at an angle theta f, then you have its component F cos theta and F sin theta. Do you remember?
Yes.
In the same way, if you will go for this, then you will if you will resolve this, it will be like this, and it will be like this. Now you will see this will cancel this because it is in opposite direction, right to left, left to right. But overall, you will see that it will be in the upward direction. It is not cancelled. That means it is polar. It is polar. And if you are going for Cl, if you are going for Cl, this Cl will attract the electron of this Cl in this direction. In the same way, this Cl will attract the electron of this Cl in opposite direction, and it will be cancelled. So mu equals to 0, and it is non-polar. And what I wrote in the first place is that if a molecule is polar, the value of A of polar molecule is greater than the value of A of non-polar. So NH3 has more value of A attractive force than chlorine Cl2. Is that clear?
Yes.
Okay, write it. Done?
Yes.
Okay. We will do some more questions. B. Arrange this in increasing order of value of A. Helium, neon, argon, krypton, xenon, radon. First decide whether it is polar or non-polar. What do you think? If an element is in elemental form, will it be polar or non-polar?
Non-polar.
Non-polar. All are non-polar, then we will go for molecular weight. Which one has greater molecular weight?
Um, Helium has least weight.
Least weight. And radon. Basically, I just arranged it in group like helium in the first group, then neon second, then argon, then krypton, then xenon, then radon. And you know that this has the least molecular weight, and this has the
Highest.
highest or largest molecular weight. So it will be arranged like this. Okay. What is the answer of C, Akifah?
Um, if 2 is greater than 0.
Just go for the polarity and non-polarity, FF and ClCl. And if you will think like this chlorine will attract this chlorine's atom in this direction, in the same way this chlorine, because both are chlorine, they will have same power. So it will cancel each other. In the same way, it will cancel each other, right?
Yes.
So both are non-polar. And if they are non-polar, then go for molecular weight. Which one has greater or highest molecular weight?
Chlorine.
Which?
Chlorine has a higher
Chlorine
weight.
has highest. So this will be the answer.
Okay.
Okay. Basically, I am arranging it in increasing or decreasing order of A, value of A.
Okay.
What is the answer of D?
Um, CH3 is lesser than C2H6.
C2H6, right? Because the CH4 is basically, this is tetrahedrally arranged at 109 degree, and it is non-polar. Basically, this is non-polar because it is sp3 hybridized and there is no lone pair. In the same way, if you will see, it will be like this. Both are non-polar. Both are non-polar. So both are non-polar, so we will go for molecular weight. This will have more molecular weight. So the value of C2H6, value of A of C2H6 will be greater than value of A of CH4. Can you solve the part E?
SO2 is less than SO3.
SO2 is
Less than SO3.
okay. Did you check polarity?
No.
Okay. First check the polarity. Whenever oxygen is a term atom, it will bond. It will be bonded with double bond. And you know that how many electrons in the how many valence electron in sulfur? Do you know how many valence electron in sulfur? 6 electron. So 4 electrons are arranged. 4 electrons are used in bonding, and one lone pair will be left like this. What about SO3? I told you that whenever oxygen is in terminal or a surrounding atom, it will bond with double bond. And you will see that this sulfur does not have any lone pair. Okay, all the 6 electrons in its valence shell are used in bonding. Okay, now see this. I'm going to show you which is polar and which is non-polar. This oxygen sulfur, which has more electronegative, which is more electronegative, oxygen or sulfur?
Oxygen.
Oxygen. So oxygen will attract electron from this sulfur. This oxygen will attract from this, and this oxygen will attract from the same. Now this is in, you can see this is on inclination. So it will have two component, like it will have two component like this and this, and it will have two component like this and this. And you can see this and this are in opposite direction, so it will be cancelled with each other, right?
Yes.
And you can see this is component of this, that means half of this and half of this. This will make a full complete, and it will be cancelled by this complete. So it will be cancelled by this. So there is no net force, or there is no net force in one direction. It will be cancelled with each other. That means this is non-polar. Are you getting my point?
Yes.
All are cancelled. Now come for this. If you are going to see this, you will see that I told you that lone pair will attract in its own direction. This oxygen will attract in its own direction, and this will attract in its own direction. It will have a resolution of vector. I just resolve. This will be cancelled. This will be cancelled by each other. But you can see here oxygen is attracting towards itself. But when a lone pair is attracting it towards itself, it will be cancelled only due to lone pair, not by this atom, because lone pair has greater effect than atom. So it will have some effect in its own direction. It will be cancelled, but not all the value. So it is polar. So SO2, value of SO2 is greater than value of A of SO3. So it will be like this. Just write it and let me know. If you are done, let me know. Okay.
Done.
Okay. One last question on this. NH3 and HCl. Which one of the following has greater value of A? First, you have to check whether it is polar or non-polar.
HCl is greater than NH3.
Done?
Yes. HCl is greater than NH3.
You will see chlorine is more electronegative, so it will attract towards itself. Now go for NH3. This is lone pair, and it will attract towards itself. Nitrogen towards itself, this from this hydrogen and from this hydrogen. Now you will see this will be cancelled with each other. Now you will see in upward direction there will be 1, 2, 3, 4. 4 arrows are going in upward direction, and in this only one arrows in right hand direction. So this is more polar than this. So this will be like this. Okay.
Okay.
Value of A of NH3 is greater than value of A of HCl. Done.
No. Done.
Okay. So this was the value of A, which represents basically attractive force. Now we will go for significance of B. That represents basically volume. Significance of B. So we can write it gives the idea of size of gas molecule. Size of gas molecule. So helium, how we are going to find out value of B? Value of B is directly proportional to size of atom, size of gas. So if I will ask the question like which one has greater value of B, value of B, arrange them in increasing or decreasing order of value of B.
Helium has lowest value and radon has highest value.
So it will be like this. What about this Cl2 and NH3?
Cl2 is bigger.
It is in third periods, that's why it has greater value. So value of value of B of Cl2 is greater than value of B of NH3. So go for the third, O2 and
2. O2 is bigger than N2.
No. O2 of you will see nitrogen after nitrogen, oxygen will come. You'll see boron, carbon, nitrogen, oxygen. Whenever we move from left to right in a period, size decreases. So nitrogen is bigger than oxygen, and if it is bigger, that means value of B of N2 is greater than value of B of O2. Okay?
Okay.
Right.
Done.
Order of B.
CH38 is greater than CH26 is greater than CH4.
Very good. And it will be like this, right?
Yes.
So here our chapter is finished. Okay. So basically we will start thermodynamics.
Actually, I have unit test on 13th February and the portion is S block elements and hydrocarbons.
Wait a minute, please. So what you want to study? S block,
Hydrocarbons.
hydrocarbon or S block, both will be coming, no?
Yes, but hydrocarbons is longer, so I want to do that first.
You want to go for hydrocarbon.
Yes.
Okay. Have you studied GOC and nomenclature?
Yes.
It's good. Wait a minute. Write a topic in chapter hydrocarbon. So, when will be your paper?
13th February.
13th February. Okay. So here it is hydrocarbon. First, going to define hydrocarbon. What is hydrocarbon? The compound which has only hydrogen and carbon. The compound which has only hydrogen and carbon is called hydrocarbon. Is that clear?
Yes.
And the compound in which hydrogen, carbon, and with along hydrogen, carbon, there will be other elements like oxygen, nitrogen. That is called hydrocarbon derivatives. What they are called? Hydrocarbon derivatives, like CH4. And if you are going to add Cl and subtract H, that means CH3Cl. This is basically hydrocarbon derivatives, and CH4 is basically hydrocarbon. Is that clear?
Yes.
Hydrocarbon are of two types. One is saturated hydrocarbon, one is saturated hydrocarbon, and another is unsaturated hydrocarbon. Another is unsaturated hydrocarbon. Now you will see what is saturated hydrocarbon and what is unsaturated hydrocarbon. Basically, organic chemistry is all about carbon. So saturated hydrocarbon, basically the compound in which carbon-carbon bond between, wait a minute, bond between carbon and carbon is single. Whenever bond between carbon and carbon is single, then it is saturated hydrocarbon, and bond between carbon and carbon is double or triple. Whatever it is double or triple is called unsaturated hydrocarbon. See the difference? The compound in which the bond between carbon and carbon is single, that is called saturated carbon and also called alkane. What it is called? Alkane. And the compound in which carbon and carbon has double or triple bond. The one which has double bond between carbon and carbon is called alkene, and the one which has triple bond between carbon and carbon is called alkyne. And you will see here it will have a general formula, that is CnH2n plus 2. CnH2n plus 2, and alkene has a general formula CnH2n, and it has a general formula CnH2n minus 2. What it represents basically is that the number of carbon, if you are going for number of carbon 1, C1, that means hydrogen will be 4. The number of hydrogen is defined by number of carbon. Carbon is 1, that means the number of hydrogen is double of number of carbon plus 2. So it will be 2 into 1, 2 plus 2. From the formula, it will be CH4. And if you are going to take the number of carbon 2, C2, that means the number of hydrogen will be double of the number of carbon plus 2, it will be 6. Yes or no?
Yes.
So if you are going for C3, double plus 2, 2 3 is 6 plus 3. If you are going for 8, double plus 2, it will be 18. Is that clear?
Yes.
And you have already studied nomenclature. The carbon which one carbon is called meth, 2 eth, 3 prop, bute, pent, hex, hept, oct, and dec. Is that clear?
Yes.
Just right. Basically, we will study alkane today. Have you studied isomerism?
Yes.
Done?
Yes.
Okay. So we will discuss only about alkane. So I will give you some question regarding this. You have already studied in previous chapter, right? Different chain isomers. Do you know what is chain isomers?
Yes.
Alkanes. C6H14. Also, right there, you pick name. Can you read this question?
Yes. Should I draw the structure?
Yes, yes. C6H14. Only the chain isomers. What is chain isomers? The molecular formula isomers. The molecular formula same, but the chain is changed.
Yes.
Should I start explaining?
Yeah. Okay. Your voice is lagging.
Should I start explaining?
Oh, yes.
Okay. You can see C6H14, and you can see that number of hydrogen is double plus 2, the number of carbon that represents it is alkane, right?
Yes.
N represents carbon carbon has single bond, in represents carbon carbon has double bond, and represents carbon carbon has triple bond, at least one, at least one. You can see right difference. C6H14. Do you know how to draw a bond line structural formula like this? or not?
Yes.
1, 2, 3, 4, 5, 6. So it is C6H14, right?
Yes.
And if you are going to draw the chain isomers, it will be like this. You can do the like this, and it will be like this too. And you can also draw it like this. Is it good? This is hexane. This is you are going to write the IUPAC name of this following. I'm going to do it in complete structural formula. C6H14, right? C6H14 will have CH3, CH2, CH2, CH2. What is chain isomers?
It will have different structures, but same molecular
It will have
formula.
different chain in their parent chain.
Okay.
Different number of carbon in their parent chain. It will be like this: CH3, CH2, CH2, CH3. You can count the number of molecular formula will be same. Number of molecules, the number of atoms in the molecules will be same. I can also write like this. Can you write the IUPAC?
First is hexane.
Wait a
Second.
minute. Wait a minute.
Okay.
Yes, first is hexane.
Yes. Second is 2-methyl pentane.
Very good. 2-methyl pentane.
Third is 3-methyl pentane.
Very good. 3-methyl pentane.
Second is 2,3 dimethyl butane.
Very good. 1, 2, 3, 4. 2,3 dimethyl butane.
Fifth is 2,2 dimethyl butane.
2,2 dimethyl butane. Very good. Very good. So, can I change the slide?
Yes.
Write the IUPAC names of the following.
Can you explain this one?
Okay. So whenever a question will be like this, it will be good if you will expand this structure. Like this is C, and here it will be CH3 whole thrice. That means it is 3 times, right?
Yes.
And on the right hand side, it is CH2. And after this CH2, it will be C. And it is just same like this CH3 whole thrice. That means CH3, CH3. Carbon always makes 4 bonds, not more than 4 bonds. Okay. Now, can you name this? Tell
2,
me.
comma 2,
Yes, 2, 2.
dimethyl
Dimethyl.
butane.
Listen to me. 1, 2, 3, 4, 5. And you will see 2, 2 methyl. And here it will be 4, 4 methyl. So we are going to write 2, 2, 4, 4 tetramethyl. Got it?
Yes.
Very good. So, can you name this, or I should start explaining?
Yeah, you can.
Sorry.
You can explain.
Okay. So we are going to expand this structure too. It will be like this. C, and here it is CH3, and here it is CH3, and here it is C2H5, and here it is C2H5. Now it expand in its simplest form, like CH3, CH3, and C, and here it is C2H5 that represents CH2CH3 and CH2CH3. Is that correct?
Yes.
Now you will see. Choose the parent chain. Wait a minute. Here it is something wrong. Something wrong because it's making only 3 bond. Oh, oh. No. Got it. Wait a minute. Let me see the question now which I have given. Okay, it's wrong. Only one carbon in between this was given. Carbon always have 4 bonds, not more than that. Will be CH3 like this, and CH3 like this, and C2H5 like this, and C2H5 like this. And I'm going to explain in its simplest form. Expand. So it will be CH3 here and CH3 here, and CH2 CH3 here, and here it will be CH2 CH3. Again, I'm going to make a mistake. Yes, you can see only one carbon. This C2H5 is directly connected to this carbon. So CH2 CH3 and CH2 CH3. Now, can you name this? You just have to write it in a better way, like CH3 C, CH3 C, and CH2 CH3, and this I'm going to write it down CH2 CH3. Can you name this? The one which is written in white? Yes or no?
3, 3.
3, 3. Yes.
3 methyl, 3 ethyl, 4 methyl pentane.
Wait a minute. 1, 2, 3, 4, 5. Right?
Yes.
So, did I make mistakes? No. CH3 whole twice. C2H5. So it will be like this. 1, 2, 3. Okay. Again, I did something wrong. Sorry. You can see here is only one carbon, right?
Yes.
This carbon is connected with CH3, CH3, and this carbon is also connected with C2H5, C2H5. And what I just did, I just write another C. This is, I'm repeating it again and again. Mistakes I have done. Now see, this C, this CH3, and also this CH3. And you can see this is CH2, CH3, and CH2, CH3. Now the correct one is here. Can you name this, please?
Two methyl.
Yes, not two. 1, 2, 3, 4, 5. 3, 3 dimethyl. Can I write?
Okay, yes.
Pentane. Okay. Can I change the slide?
Can you show the question ones?
Yes, why not? This was the question.
Done.
Done. Very good. Now, preparation. We are studying alkane, so I'm writing preparation of alkane, how we will prepare alkane. Okay, so there will be some methods to prepare alkane. The first one is from unsaturated hydrocarbon, from unsaturated hydrocarbons. So what is unsaturated? Basically from alkene or alkyne, how we say, from alkene or alkyne, we prepare alkane. Okay. It is also called basically hydrogenation. It is also called hydrogenation. I can write with me. Dihydrogen adds up in alkene or alkyne to give alkane. This is also called, this process is called hydrogenation. That means addition of hydrogen. This process is called hydrogenation. Okay. How it added? I just told you that how many bonds does
Sorry?
how many bonds does carbon make? How many bonds does carbon make?
In alkene?
No, no. Carbon generally, how many bonds
Four.
carbon have?
Four bonds.
How many?
Four.
4. Only 4. Whether it is alkene, alkyne, or alkane, it will have 4 bonds. So you can see CH2 double bond CH2, or you can write for better understanding. I'm going to write it like this: H, H, and you can count the bond of each carbon. How many bond of carbon? One double, that means two bond, and here it is one single that represents 4 bond. And we are going to add H2 in this, in the presence of nickel, palladium, platinum. This is catalyst, and this is hydrogenation. Hydrogenation represents addition of hydrogen, and carbon cannot have more than 4 bonds. That means it has to break this bond. To add something, it has to break the old one, and it will be like CH, H, and it will be single bond H and H. Now this hydrogen will go and attach with each one of the carbon, and it will be alkane. You can see here it is ethene, and here you can see it is ethane. Is that clear?
Yes.
So answer me this with IUPAC. What will be the product? This is catalyst to increase the rate of reaction. Catalysts are used. So today we will have a class of 1.5 hours, right?
Okay.
Akifah?
Yes. It gives C3H8.
CH3, right? This I just wrote the left one.
Yes.
Speak up.
C3H8.
C3H8.
No, total it's C3H8.
Okay, tell me individuals, like I wrote CH3, then
Um,
your voice is lagging.
CH3, CH2.
2CH3. What just happened is that you have to break this bond, and it will have three bonds. So one of the hydrogen will come and attach to this carbon, and it will also have three bond, and one of the hydrogen will come and attach to this. Okay,
Okay.
can I change the slide?
Yes.
Okay.
CH3, CH2, CH3.
What you just said, CH3.
CH2,
Very good.
CH3.
One bond, if one bond will break, it will be like CH3, CH, double bond, CH2. One hydrogen, from four hydrogen, one of the hydrogen will go to this, and one of the hydrogen will go to this, and H2 will be left. Two hydrogen will be left. Then again H2, in the presence of nickel, platinum, palladium, and this bond will break, and one of the hydrogen will go to this, and one of the hydrogen will go to this, and it will be CH2 and then CH3, right, Akifah?
Yes. Yes.
Okay. So this was the first preparation of alkane from unsaturated hydrocarbon. Second, from alkyl halides. From alkyl halides. What is alkyl? Basically, this is carbon, the chain of carbon like methyl, ethyl, propyl, butyl. So R, and what is halide? Halide is for halogen. X. Halogen is for fluorine, chlorine, bromine, iodine, right?
Yes.
So I'm going to write a point about this. Alkyl halides except fluorides, not for fluorine, it is not for fluorine, except fluorides On reduction with zinc and dilute hydrochloric acid gives alkanes. Concentrate here. If there is a alkyl halide like CH3Cl, not fluorine. If fluorine will present, this will not be happen. Okay. CH3Cl will be added into H2 in the presence of zinc and dilute hydrochloric acid. That means dilute acid. What will happen? This bond will break, and H2 is like this, and this will break, and this will go to this, and you can see CH4, it will be CH4, and from here this is H plus and this is Cl, it will combine with each other and it will be HCl. In the same way, if we will have CH3CH2Cl, will be adding into H2 in the presence of zinc and H plus, the answer will be CH3CH3 and HCl will be our byproduct. This will break down and one of the H will go to attachment and one of the H will add with this. Is this clear?
Hello?
Can you name this? Can you write the IUPAC of this and this?
I don't know.
You don't know. Okay. Just write it and let me know if you are finished with this, then I will explain.
Done.
Done. Actually, I was given like this CH3. So you can name it like this. This is for 1 chloro and 1 carbon is for meth and single bond is for methane. If it is given like CH3, CH2, Cl, you can give numbering like 1, 2. So 1 for 1, it will be branch 1 branch, substituent 1 chloro, parent chain 2 carbon, eth, and then single bond, that will be ethane. Is this clear?
Yes.
Name the IUPAC name of the reactant as well as product and write the product.
1-chloropropane.
Product propane.
Yes.
Okay.
Product.
And what is the name of reactant? Wait a minute, Akifah.
Okay.
What is the name of this reactant? You can give the numbering like 1, 2, 3, and it will be 1-chloropropane.
Propane.
Very good. 1-chloropropane. Yeah, write it. If you are done with this, let me know. Done, Akifah?
Done.
So it is basically from alkyl halide we have one part. From alkyl halide, this is the first part. And from alkyl halide, we have another part that is known as B part. That is basically Wood's reaction. You can see Wood's reaction. What is Wood's reaction basically? So I'm going to write first alkyl halides on treatment sodium metal in dry ether. Basically, dry ether is used because it is very reactive. That's why dry ether is used. That is free from moisture. Free from moisture. Dry ether solution gives alkanes. This reaction is known as Wood's reaction. This reaction is known as Wood's reaction. First write it, then I will explain how you will tackle this question.
Done.
Very good. Now see how we will do this question. Whenever the question is like, whenever there will be question like alkyl halide, this is alkyl halide. React with sodium in the presence of dry ether. If there will be sodium and there will be sodium and dry ether, this will be, and there will be alkyl halide, this will be Wood's reaction. And what happens is this Br will be omitted with Na and it will form 2NaBr as a byproduct, and this CH3 will connect with this CH3 and it will be like CH3 ethane.
Okay.
And the question will be also like this: CH3Br and plus 2Na in the presence of dry ether. Then you have to keep it in mind that whenever there will be Na in the presence of dry ether, it will double the product, it will double the reactant. This is only CH3 is present, that means it will double it and it will be like this. You have to make it twice and then 2NaBr will be left in the byproduct. Are you getting my point?
Yes.
Okay, then do this. So in the next class, basically we will